Hello and welcome everyone to our lecture series on classes in C++. We've already taken a look at how to create a simple class. This lecture is called Classes Part 2. And we're going to take a deeper dive into all of the things we can do with classes. Right. So as an overview, this series will be broken down into smaller videos. And we're going to cover all of these topics in this lecture series. We're going to actually start off with what is called the this pointer. Right? So inside our class, there is actually a pointer which is named this, THIS. So let's take a look at an example class. So we have this class person, and we want to know when we create an object of type person. So here in main, right, we're going to create an object named Milo of type person. We want to know, how does C++ know which object called one of these class functions? Right here, if we call Milo.getAge, right, how does C++ know that? Right, and actually it has a hidden pointer called the this pointer. Let's take a little better look at the code from here as just a review of classes, because we haven't spent too much time with classes yet, right? So here in the .h file, I've declared a class named person, right? The one on the lecture slide was a little bit smaller, harder to see all in one file, so that's why I wanted to go ahead and give you a copy of these files so you could take a look at them, work with them, test them, right? So in the .h file, I'm including the string library because we're going to have a member function that is of type string. So remember, when we define a class, we use the keyword class, and then we give the class a name, in this case, person. When we define the class, everything goes inside the curly brackets, and then we have to have the semicolon at the end here. And then within the class, we can specify whether access to our functions and our data members, whether the access is public or private. There's also a protected version, but that has to deal with inheritance, so we won't discuss that yet. So what we're doing here at the top, right, I've got the public label here, this keyword followed by the colon. And so everything after this will be public until we hit the private label here. Remember, every class has to have a constructor, and the class constructor is always the same name as the class. So the class is named person, the constructor is named person. And this constructor function has no return value. That's what's unique about constructors. Right? We always want to create a default constructor, and then sometimes we create initialization constructors as well too. Notice what I've done here is this constructor, we can pass two arguments to it. So it has two parameters. One parameter is called name P, it's of type string, and it's the empty string. So I'm using default arguments here. So remember, in the function prototype, you can specify a default argument simply by using the assignment operator followed by whatever the default is. Meaning, if I don't pass an argument for name P, it will then be instantiated, right? It will be initialized to this default argument of empty string. And I've done the same thing here too for age P. If we don't pass this integer argument to the function, then our class data member age will be, this parameter value will be assigned the value of 0, which eventually will be assigned to age, because that's what the constructor function does. It initializes the member variables. Right. And this class so far just has two accessor member functions. One is getName, which will just return what's stored in the name variable, and then getAge will return the age. And we've made our variables private. That example in the lecture slides, I've got a note telling you that making them public is not the best idea. I believe when I did that, I was trying to get everything to fit on the same slide, and putting that extra label in there made it kind of unreadable. That's why we've got these files here. All right, so these data members are private, meaning once you create an object of type person, you cannot get to these data members without a function that gives you access to them. And I don't have any setter functions in this example, right? But we could add them. So once we've defined our class within our header file, then in our CPP file, so person.cpp, here I've included person.h. So we have access then, so this file knows what the class person is. Within here, we're going to create our constructor function. So our constructor function here, right, looks just like right here. This looks just like the prototype, has the two parameters. Remember, we have to scope it then with the name of the class. That's how we know, or that's how C++ knows that this is a class member function that we're defining, right? And then I've done something that we have looked at yet in class. I'm using initialization. So there's a couple different ways we can do this. What we've seen before is that within this function, right, I can just simply set the class data member name equal to name P. And we could set the class data member age equal to age P, the parameter age. So that's one way to initialize your arguments. Initialize your class data members to the arguments passed to the function. Right. But the other way to do it as well is right after the function header, you put the colon, and then you can put a list right here of this is the class data member name. Within here, I want to initialize it to name P, comma separate if there's more than one. And then I want to initialize age to whatever they passed here as age. So we're just taking those default values. We're not doing any type of error checking, right? To maybe see if age is like a negative number. We just don't really care about that in this case, right? So that's another way of then using this initialization procedure to actually then initialize your class member variables. Our other two functions then, right, get name, right, get name. This looks just like the prototype. It's going to return a string. Remember then, we scope it again with the class name followed by the two colons, which in C++ is the scope resolution operator. And we're just going to return the name. And we do the same thing here for get age, right? It returns an integer because the age is an integer type. Scope it with a class name, and we just return age. Over here in main, then we want to show how we can use the class. And here, let's just, I had recopied the class here, but we really don't need that. You can define everything all in one function. For a simple example, we tend not to do that. So let's clean this up. And then notice here, I've included person.h, I've included IOStream because we're going to print out some information. So let me space this out a bit. So right here, we're going to create an object of type person. That's our class data type we've defined. The object's name is Milo. We're going to initialize then Milo's name to Milo here in double quotes and the age to 21. So we'll pass those arguments to the constructor, and we should see now when we print out, we're going to call the function get name so we can see what name it's stored in the name variable. And we're going to call get age so we can see what it's stored in the age variable as well. So remember, whenever you use the member functions, right, you use the object name. So this is our object Milo. Same thing as an identifier. We tend to call these objects in C++, object-oriented programming. We think when we define a class, we're defining an abstract idea of an object. In this case, the object would be a person. The object type. The object's name is Milo. There, I didn't mean to confuse you. I likely did. Sorry if I did. But Milo.getName, the dot operator, we need to use that to actually then call the member function. And I didn't mean to move that. So that's just the syntax of working with class member functions. And let's see over here. I have a make file to build this. Create an executable a.out. Notice when I run it, we're going to see Milo's age is 21. let's take a look while we're here, before we get around to talking about the this pointer. Let's take a look at what happens if we declare Milo using the default constructor. So I'm going to say person Milo. Oh, and I'm just going to do this. So whenever we declare an object of type person, right, there's the name Milo. If we do not pass any arguments, if we just do it like this, the default constructor is called. We do have a default constructor simply because we've provided default arguments. This function knows how to behave if there are no arguments passed to it. And again, if I remake that, nothing to be done. Okay, I forgot to save my file. So let's rerun that. Let's rerun our executable. Well, now it just said apostrophe S age is. So the default for Milo's name was the empty string. That's why nothing printed out here. And the default for the age was 0. So we see apostrophe S age is 0. So there is nothing stored in name. And really, if we just wanted to pass one argument, and if I just want to go ahead and pass the argument Milo as the name, but not pass it the age, then we should see it gets the name Milo, but it will default to the age of 0. So as you can see here, what was printed out is Milo's age is 0. And the way default arguments work is we can't actually just pass this. We can't just pass the age. We can't just say we want to use the default for the name and then just pass the age. When we've declared something with a default argument, once we do not pass the first item as a default, then it wants to use the rest of the items as a default. And actually what I should more properly say is because name is the first parameter here, when we call this function and we only pass one parameter, it's going to think that we're trying to pass a 0 to the name. And instead of 0, why don't I just do the 21 since 0 is a default. And let's see now if we rebuild this, right? Notice then we get an error. It says there's no matching function call to person of something of just type in. All right, it's gone to the class and it says, oh, I don't have a function, a constructor function named person that just takes an integer argument. So it doesn't know what to do with that. Like I said, we have to, when the first one is a default, we have to at least pass something of type string. Otherwise, when they're all defaults, right, we do that to have the default constructor. We use all the default arguments. All right. So again, as you work with default arguments, the only way to really learn these things is to create some of these functions with defaults, try passing different parameters, get those error messages, figure out why it's giving you that error, right? That error then will teach you a better understanding of how to use default arguments and anything in coding. It's often trying to understand the error, though, that is the problem. All right, we got a little bit off track there, but that just gave us a review of classes, right? Back to our concept now of the this pointer. So that was our generic person class. What's happening is underneath, then C++ has a pointer called this, THIS. And so when we write a function, like the Milo get age, when we call Milo.getAge, right, it looks just like that. We're not passing any arguments. But what the compiler is doing is when we write our function with a prototype of return data type int, the name is getAge, no arguments. What the compiler has done is it has changed our function. It still has a return data type of int. It still has the same name, but it adds in an argument that is a pointer to our class type. So our class type is person. So person star is a pointer to a person type. Const, right? Const pointer means it can only point to whatever object that we pass to it. It can't point to any other class object. And it names the pointer this. And it changes the code inside our function, we wrote return age. Because this is a pointer, it says return this, and it uses this arrow-like notation, the hyphen and the greater than sign. So it uses the this pointer to point to the class data member age. So it changes our code to look like this. And what happens is this is what the function prototype looks of our code, right, after it's compiled. And then when we call our function, actually what's going to happen is it's going to pass a reference to our object. So again, every class has a this pointer. The compiler implicitly adds a hidden const pointer that holds the address of the object. Right? So inside the member function, any class members, functions, and variables are updated to refer to the object by adding the prefix this, I'm going to call it this arrow to each member. So this arrow this pointing to age, right? That arrow looks like a pointer, right? So what the compiler does is when we then in main say milo.getAge, right? It passes the address of our object Milo. So basically we write Milo.operator getAge, empty parentheses to let it know we're calling a function. But what it does is it changes what we've written in our program to look like getAge past the address of Milo. And right, it's my assumption this was done in the language because it's easier for us to follow this structure of Milo.getAge and not, it doesn't require us then to always manually type in these pointers and then remember that we're first argument's a pointer and then be forced to pass this extra argument. This is happening underneath, but we do need to be aware of this pointer because we will get to we'll get to a point. I shouldn't use the word point with pointer. Eventually, when we write copy constructors, when we write assignment operators, that we'll actually have to use this pointer in some of our code. Right, so that's why we begin to bring it up now. So that is how then when you call a member function, it knows what object, because if we had multiple objects in our code, right? If we had multiple objects, I think in my next example, I make like a person named Minnie for Minnie Mouse. And we're just going to say Minnie is 18, right? So if we want to then access the class member function for Minnie, right? We write it like this in main. But what's really happening is the compiler changes Minnie.getName, our code to getName address of Minnie. So only Minnie then can access her name and her age. Only Milo can access his name and his age, right? It doesn't then allow us to pass, right, a pointer to some other object in there. It also protects against that as well. If we wrote it in another method, another way, we could get around the private access as well. That's a subject for much later, some sort of advanced class where we're doing things that, you know, we can to access the data, but we shouldn't be doing. We don't do those things. All right. So that's an idea of what's happening, right, with this pointer. I'm sure right now you're thinking, oh, good grief, another pointer. And so that's what this next slide does, right? It gives us an idea of what we just talked about. And so actually, then this pointer is a parameter that goes on to the stack. If we were to go out and look in memory, we would see that there is a pointer to that object out on the memory stack, right, while that function executes. So it handles all that in the background. We don't have to worry about that. We just want to be aware of it right now. Right. sometimes when you look at coding examples, you will see people actually using the this pointer. So here's an example of a simple class, right? The class's name is example. It has private data of type int. It has one data member named data. It has a public constructor function, same name as a class example. In this case, the constructor just takes the data argument. There is no default at this point. But what happens then is people will then use the same name for the parameter as the name of the class data member. And what they do is they use the this pointer. So they say this, right, arrow data. So this is the class data member, and assign the parameter to the class data member. So they do that to show that this.data is the member variable. Over here, data is the local parameter. So you'll see people doing that. Notice then, right, in my example here, purposely said, I didn't make the name of the parameters the same as the data member names. If I were to do that, so I call that name P for like name parameter, age P for age parameter. So if I were to do that, actually, if I were to do that here, and then get rid of this initializer here, and if we were to say name equals name here, and age equals age, that's really confusing. Is this name right here the parameter name, or is it the local, is the class data member name, right? Is the local parameter the class data name? Which is why if we say this name and this age, this says, sorry, using the word this a lot, but I guess that's why they call it the this pointer, right? Class data member, this.name, class data member, not this pointer age, class data member, not, sorry, I accidentally said dot with this pointer name. So this is the local parameter, and this is the local parameter that's been passed to the function. These are class data members. So you'll see people doing that then so that they can use the same names in the parameter list as the class data names. When I learned C++ programming, this at least wasn't done in my class by my professor. So we always named the parameter something different from the class data members to make it less confusing. Right. And that's all we want to say right now about the this pointer. That's the end of this video segment. I'm using the word this a lot. Thank you for watching. In our next upcoming lecture, we will start talking about friend functions. Obviously, if you have any questions or anything at this point about the this pointer, I would say wait until you've seen it used more. That will begin to answer your questions. Not that it's ever bad to ask a question, but with experience, then you will arrive at a better understanding.